What is it being in first null here? Okay, we know that for broadside array case here, you know the value. Electric field is equal to sin n psi by 2 divided by sin psi by 2 here. So delta is equal to 0. That is nothing but a phase difference between the two existing sources is equal to 0. Okay. So if at all that is the case here, then beta d is equal to cos phi plus delta was that delta is equal to 0. So it is as it is now. So it's equal to plus or minus 2k pi divided by n here. Okay. Then what will be having? Just substitute the value of beta is equal to 2 pi by lambda n. No need to substitute the number of isotropic point sources or the distance between the isotropic point sources here. So let us put only the beta is equal to 2 pi by lambda. So we'll be having phi is equal to cos minus k into lambda divided by n into t here. So what is this beam between first null here? It is 2 into angle between first null and the maximum of the major node here. That is nothing but here you can place the gamma here. Okay, gamma is nothing but here angle between the first null and the maximum of the major node here. So this gamma is nothing but here which is going to lie between phi is equal to 0 degree and phi is equal to 90 degree here. Okay, this is where the gamma is going to lie. Hence, what we can write here is phi is equal to 90 minus gamma here. Okay. So 90 minus gamma is nothing but here. You can take from the RHS side cos inverse to the LHS side here. So it will become cos 90 minus gamma here. So 90 minus gamma could be written as sin gamma is equal to plus or minus of k lambda divided by n into d here. Let's consider the gamma is very small here. So then gamma is equal to plus or minus k into lambda divided by n into d. If at all I consider the value of k is equal to 1, then gamma 1 is equal to plus or minus lambda divided by n into t here. Okay, this is how we can explain regarding the beam utility first null here. Okay, now let us go to the end fire case here. Okay, so till now whatever we have learned is regarding the broadside array case here, where delta is equal to 0, we have to substitute in the total phase difference here, right? So now you have to substitute delta is equal to minus dr here. Okay, so let us substitute that one here. So again we have to go for minor lobe maxima here. So we know the value of E here, total electric field from all the point sources which are linearly arranged here, right? N psi by 2 and sin psi by 2 here. Again, if at all you wanted to find the middle of maxima here, sine of something should be equal to 1. That is, but your sine 90 is equal to 1 here. So sine this n psi by 2 is equal to 1 here. So n psi by 2 is equal to plus or minus. Again, you have to put the same value 2k plus 1 pi by 2 here. Okay, psi is equal to 2k plus 1 into pi by n here. 2 to get cancels here. Okay, so you know the end fire case is delta is equal to minus beta d. Okay, that is nothing but here phase difference is equal to dr cos phi is there plus delta was there. Instead of delta here, what you have to do? You have to substitute minus dr here, right? So so again here we have to substitute minus dr is nothing but here because it beta into d here. Okay, so the dr is nothing but here you can consider radian here. Okay, so beta into d have to substitute here. Okay, so beta into d have to substitute means you take beta d as a common here. Okay, cos phi minus 1 will be there. With beta d you can take it to the RHS side here. Okay, you will be having cos phi minus 1 is equal to this value. Okay, so now if at all we consider n is equal to 4 and t is equal to lambda by 2 here, if at all we substitute these values here, we are going to have cos of minus 1 is equal to plus or minus 2k plus 1 divided by 4 will be having here. Okay, cos phi is equal to plus or minus 1 2k plus 1 divided by 4 plus 1 will be there here. So phi is equal to, we will be having the whole value as plus or minus 2k plus 1 divided by 4, okay, plus 1. Now substitute the value of k is equal to 1 2 3 and 4. You will get certain value regarding the phi here. Okay, if at all you will be having cos inverse of something is greater than 1, it will not be a valid one here. So hence only the value which is less than 1 will be considered a cos inverse brackets here, right? So again let us go for pattern maxima here. Same thing you have to do here. Again sign of something should be equal to 0 here. That is sine n psi by 2 is equal to 0 means n psi by 2 equal to something value. It should be having the multiples of 180 degree here. So that's why I will be having plus or minus k pi here. Okay. So psi is equal to plus or minus k pi into 2 divided by n will be there here. In the end fire case again you can substitute delta is equal to minus beta d, or you can say minus dr here. Okay. So remember here d is equal to 2 pi by beta is equal to 2 pi by lambda here. Remember beta is equal to 2 pi by lambda here into d. If you do here, that will become here dr here. Remember. Okay. 2 pi by lambda into d, if you do it, that is becomes dr. Dr will be in terms of radians here. Right. Okay, so delta is equal to beta into d here. Again, substitute the same thing here. We will be having certain value cos of pi minus 1 is equal to plus or minus 2k pi divided by n beta d here. So if at all you are substituting the n as a 2 point sources as equal to n is equal to 4, okay, and d is equal to lambda by 2 and beta is equal to 2 pi by lambda here. So you will be having certain value, that is again in the previous case we were having cos of phi is equal to plus or minus k by 2 here. Now in this case we are having plus or minus k by 2 plus 1 here. Just adding 1 to this, we have the pattern minimum of end fire case here. Okay, so again you substitute the value of k is equal to 1, we will be having plus or minus of 60 here. Then again it will go to k is equal to 2. If at all you substitute k is equal to 2 by 2, it is 1 here. Okay, plus 1. If at a plus 1 and plus 1, if it is more than 1, minus 1 and plus 1 if you consider here, you be having 0. So cos inverse of 0, you have certain value here. Okay, so this is how we are going to get the k value and here in the case of direction of pattern minima. Okay, in the end fire case here again. So if at all you draw the diagram concerning the end fire case here, as I have described here again, end fire case you will be having the maxima, or you can say that maximum direction will be along the axis of the array here, and it is called as end fire array case here. See here you can see the pattern of minor lobe here, that is maxima pattern of minor lobe is 75.5 degree here that you got here already. 70 plus or minus of 75.5 degree, same thing plus or minus of 75, that is maxima pattern here of the minor lobe here, right? Again 60 degree minus 60 degree you got from here to, that is where you are having the null directions here, where there are no radiations have been generated here. Okay. This is how you can get the end fire array case here. Okay, so let us move on to the next topic, that is very similar one again, beam in personal here. In this case again you have to do the delta is equal to minus beta d here. Substituting, you will be having the value as cos of pi minus 1 plus or minus 2 k pi divided by n beta d here. Okay, you know the I just wanted to bring in terms of sign here. So that's by cos phi is equal to what you can say 1 minus 2 sin square pi by 2 here minus 1. Okay, so again for beta is equal to 2 pi by d, minus 1 get cancelled, minus 1 plus 1 get cancelled here. So remaining is again you will be having here beta is equal to uh, beta is equal to 2 pi by lambda here. Okay, just substitute the value of beta here. Need not to substitute the value of n and d here. Okay, so just substitute the value of beta here. Beta is equal to 2 pi by lambda here. Okay, so 2 get cancels and pi get cancels here. So we'll be having 2. We'll be having k pi divided by 2nd here, right? So these two values will come to the denominator here. So again, square value is there, just square rooting of the on the RHS side here. Okay, so pi by 2 sine inverse of the value here. Pi is equal to 2 sine inverse of whatever the root plus or minus k pi divided by 2 nt here. Now you can consider sine inverse of something is equal to the value here. Okay, approximately. So pi is equal to, will be having plus or minus of 2 into k pi divided by n into d here. You know the formula of beam width between first null here, 2 into whatever the angle between the first null, okay, and the maximum direction here. Okay, so that is nothing but 2 into root of 2k lambda divided by n into d here. So for t is equal to 1 here, L is equal to L into lambda here, consider here, L is equal to, L is nothing but here length here. Okay, n into d, number of whatever isotopic point sources are there, and the distance between the point sources. Here is nothing but you can write it as a length here. So that's why L it is can write here. Lambda I can take the number side. K is equal to 1 you can write. So you'll be having final equation 2 into root of 2 divided by L by lambda here. First the length, the end Faraday case here. Okay, if at all you wanted to convert it into this into degree form here, what you have to do here is 2 into 180 divided by pi here. So you'll be having 114.6 the root of 2 divided by L by lambda. Directly you can write this equation here. If at all they have been asked you to find out in terms of degree here. Okay, so being in first term in degree, you can write 114.6 degree root of 2 divided by L by lambda here. If at all you have been asked to find out the half power beamwidth between half power beamwidth, so you can write it 1 by 2 into beamwidth in first null here. In the case of n Farad case here, so you can write 57.3 degree into root of 2 divided by L by lambda here. Okay, this is how we can explain regarding the linear array of anisotropic point sources, broadside array case, and end fire array case here. Okay, so these are the formulas you have to remember here for the sake of problem solving here. We will the first null and half power beam width here. Okay, sometimes it has been asked in the examination also regarding the derivation and all these things here to get down to the pattern maxima and pattern minima of end fire case, and pattern maxima and pattern minima of broadside array case here. At time you have to solve all these things here. Okay, thank you.